All right, good. So, hi, I'm Thomas Jaenich, and I'm happy to present the work that I've done together with Graham, Mcdonald, and Iadh Ounis. So, traditionally, in information retrieval, we are focused on relevance, right? And we want to provide the most relevant search results to the users. However, as many research has shown, and also as the previous speaker has motivated, if we only focus on relevance, we might discriminate against certain groups. So in my research, I try to find solutions how we can balance relevance and fairness for groups of documents to have both of them in the search results. When I talk about groups of documents, I talk about documents that can be grouped by shared attributes, for example, like geographic location. So the main goal is that all groups should be ranked fairly while keeping the search results relevant. And specifically, I focus on exposure fairness, right? Exposure is the probability of a document being observed by a user. There are different user models that can be used to measure exposure. I'm using the one that also has been used in the track, or you might know maybe from the DCG. And as you can see in the example ranking, the higher up a document is in the ranking, the more exposure it gets. So the other way around as well. The further down a document is positioned in the ranking, the less likely it will be exposed to the user. And when I talk about groups, we calculate the exposure over groups as well in our research. So to be even more specifically in this kind of work we're doing, our fairness notion is that all groups should receive an equal exposure in the search results. And what you can see here is a standard pipeline. And in the standard pipeline, we usually have like a lightweight retrieval at first, where we do a first stage retrieval, and then we apply a re-ranker on this first stage retrieval to get some search results, right? And then now I said we want all groups to receive an equal exposure. If we look at the example ranking here, where we have documents from the red, yellow, and blue group, we can see that unfortunately the final ranking is not fair, because the red and the blue group, they receive similar exposure, but the yellow group doesn't. And we found that a big factor when it comes to this is the first stage retrieval, that if we don't retrieve enough documents in the first stage retrieval, re-ranking might not be sufficient anymore to achieve our exposure goals, right? And yet now you might argue, okay, what if we're really smart at re-ranking, right? What you can see here is a graph for a top 100 ranking that shows all the possible exposure values we can get per group when they have a certain amount of documents. And what we can take away from here is that re-ranking can only achieve limited exposure, right? And we argue that even better than re-ranking, when we want to increase the exposure, is adding more documents from the group, and that means we need to have them in the first stage retrieval. That's why we came up with the question, okay, how can we increase the recall of documents from underrepresented groups in the first stage retrieval? And one state-of-the-art method to increase the recall is adaptive re-ranking, which was introduced by McAvaney et al. At SIGIR 2022. And I will briefly describe how this adaptive re-ranking works. So we start out once again with a simple retriever that gives us the initial retrieval. From this initial retrieval, a batch of documents is taken and is then scored by the re-ranker. So far, everything as we know from the standard pipeline, right? But then the scored batch of documents is added to the final results, but also we're using a graph component that holds the related documents to the ones that we've just scored and find similar documents, right? We find the documents for these and add them to the frontier, and in turn add them again to the re-ranking pool. This way, we discover more documents from the first stage retrieval that are potentially relevant as well. And then, after we've added them to the re-ranking pool, we obviously score them with the re-ranker again and add them to the final ranking. And a bit more details. So these batches of documents, they're taking alternatively from the initial first retrieval and then from this frontier that I've just described. There is a predefined budget, so that needs to be predefined until we do this process. And yes, that's what I said. Every time a batch is scored, unseen neighbors are found with the graph component. And we ask ourselves, okay, can we use this adaptive re-ranking process that increases the recall for our fairness objectives, right? Can we find documents from underrepresented groups? And in the work, we came up with a couple of policies that modify this adaptive re-ranking process. One of them is a pre-processing policy. What I mean with that is that this policy is applied during the graph construction, and the other policies that we have, they're applied in an existing graph, right? When we have an existing graph component, we can apply the policies in there. So first, the pre-processing policies. So what we want with the first policy is to achieve that only documents from different group than the source documents are considered as neighbored. So remember when we had, when we go to the graph, we had a scored documents, and for this document we try to find related documents. But what we want to do now here is we have a document from, well, too close, a document from group A, which we scored. And then what we want to do, we want to find similar documents from different groups. And in policy 2, what we do is we use a quota system where we basically enforce that an equal amount of neighbors exist for every document. Now to the in-processing policies. So these are the policies that are applied in a graph that already exists. So in policy 3, we do something similar that we did in policy 1, just at a different stage. So what we do is that neighbors from the same group as the source documents are removed from the selection process. And in policy 4, what we're doing is we enforce equal proportions of documents from each group. So you can see how they relate to each other. Policy 1 and 2 and policy 3 and 4, they're just at different stages of the process. Then we also modify the selection process when we select the batch of documents. It means that we select the documents, only the top scored documents from each group to be added to our re-ranking pool. And in policy 6, what we're doing is that we change the order of the selection process of the standard adaptive re-ranking process. That means that documents are added to the re-ranking pool in the order they were added to the frontier. And to evaluate our policies, but also answer the first question, whether we can use SIGIR to increase the recall and to use it for fairness objectives, we came up with a few research questions. There are more in the paper, but in this short time we only focus on these 3. The first one is, does adaptive re-ranking lead to a fairer distribution of exposure compared to the standard re-ranking pipeline? So if we apply this adaptive re-ranking, does it help out of the box right away? Maybe we don't need these policies. And the second research question, we see whether our policies actually increase fairness. And the third one, remember, relevance is still important, right? Because if we're just being fair, but relevance is out of the picture, the system is unusable again, right? And these are the three research questions. And in an experimental setup, we used the fair ranking track collections from the years 2021 and 2022. You can see in the table the different categories and their associated groups. And as baselines, what we did is we used the standard re-ranking pipelines, like you can see here, BM25, and then re-ranked by T5, but also the standard adaptive re-ranking pipelines. As metric, we used the attention-weighted ranked fairness. For relevance, For relevance, we use NDCG, and because to measure the trade-off, we use the product of both, and we follow here the fair ranking track with the selection. So the first question is, okay, does GAR, adaptive re-ranking, improve fairness out of the box, right? And I was a bit surprised by this because I thought, okay, we're increasing the recall, so there might be a good chance that it would work out of the box. But turns out in our experiments that deploying GAR does not increase fairness. Thanks. It actually decreases fairness compared to the standard re-ranking pipeline. So the next question is, of course, do our policies increase fairness then? Right? Do our interventions actually work? And we can see here in AWF, in this metric here, higher is better, right? And we can see here that the normal pipelines, they actually have room for improvement. And I'm happy to say that we can make use of this room for improvements. All of our policies are actually able to improve fairness, so that means to distribute the exposure equally over the groups better than the pipelines, than the baselines. And what we can also see is a trend that our in-processing policy, where we change the batch selection, achieves the highest values in the metric, so achieves the best fairness values. And of course, the next question is, how is relevance affected? And we can see here in the table that there are only marginal differences in NDCG. So we're doing pretty well. And sometimes we even outperform the baselines, but I'm being very careful when I say outperform here because the differences are so small that it's, yeah, not very remarkable. But you can see that we're in the same area when it comes to this. And this is obviously then reflected in the trade-off between relevance and fairness. We can see that all of our policies actually outperform the standard re-ranking baseline and the adaptive re-ranking baseline. These results, by the way, because maybe you're asking yourself why you're only seeing the results for Electra, they hold as well for when T5 is applied. And overall, yes, okay, last minute. Overall, we can see that policy 6 is our best performing policy. Yeah, to conclude, we found that adaptive re-ranking out of the box does not increase fairness compared to the standard re-ranking pipeline. We can see that our policies are able to improve fairness while maintaining the relevance. And our best performing policy can actually be deployed in existing graphs already. So that means we don't have to construct a new graph. And that's it. Thank you for your attention.